Thermal energy, conduction, convection, and radiation. Thermal energy is a vital part of our everyday lives. It plays a role in everything from cooking food to heating our homes. Understanding how thermal energy moves and interacts with different materials helps us learn more about the world around us. We will explore three main concepts: methods of thermal energy transfer, the movement of thermal energy from warmer to cooler areas, and the relationship between temperature and kinetic energy. There are three primary methods through which thermal energy transfers: conduction, convection, and radiation. Each method has unique characteristics and examples in our daily lives. Conduction is the transfer of thermal energy through direct contact between materials. When you touch a hot stove, thermal energy moves from the stove to your hand. This happens because the particles in the hot stove vibrate quickly, transferring energy to the slower-moving particles in your hand. Metals are great conductors of thermal energy, which is why cooking utensils are often made of materials like stainless steel or aluminum. Convection occurs in fluids, such as liquids and gases. It involves the movement of warmer fluid rising and cooler fluid sinking, creating a circulation pattern. When you heat water in a pot, the water at the bottom gets hot first. This warm water rises to the surface, while cooler water sinks to the bottom, creating a cycle. This process is not only important for cooking, but also plays a significant role in weather patterns. For example, warm air rises, cools, and then sinks again, leading to wind and currents in the atmosphere. Radiation is different from conduction and convection because it does not require a medium to transfer energy. Instead, thermal energy moves through electromagnetic waves. A good example of radiation is the sunlight warming your skin. The sun emits energy that travels through the vacuum of space and reaches Earth. This energy warms the surface and is absorbed by the ground, water, and living things. Thermal energy always moves in a predictable pattern, from areas of higher temperature to areas of lower temperature. This process continues until thermal equilibrium is reached, meaning that the temperatures equalize and no net energy transfer occurs. For example, if you place an ice cube in a warm drink, the heat from the drink will transfer to the ice cube, causing it to melt. As the ice melts, the drink cools down. Eventually, the drink and the melted ice will reach the same temperature, achieving thermal equilibrium. In nature, this principle can be observed in various situations, such as weather systems. Warm air rises, creating low-pressure areas, while cooler air sinks, leading to high-pressure areas. This movement of air helps to create wind and weather patterns that we experience every day. Temperature is a measurement of how hot or cold something is, but it is also closely related to the kinetic energy of the particles within a substance. Kinetic energy is the energy of motion. When an object heats up, its particles move faster. For example, when you heat water, the molecules move more quickly as the temperature increases. This increase in motion means that the particles have higher kinetic energy. When a substance cools down, its particles slow down, resulting in lower kinetic energy and a decrease in temperature. This relationship is crucial in understanding how thermal energy behaves. It explains why materials expand when heated and contract when cooled. In conclusion, understanding how thermal energy transfers is essential for students to grasp basic scientific concepts. By investigating conduction, convection, and radiation, students can appreciate the different ways thermal energy interacts with matter. Recognizing how thermal energy moves from warmer to cooler areas until thermal equilibrium is achieved is fundamental in both nature and technology. Finally, the relationship between temperature and kinetic energy helps understand the behavior of particles in different states of matter. Through these concepts, we can better understand and appreciate the role of thermal energy in our world. Please hit the subscribe button below